Teaching testing of hypothesis. So last day we have said that we have talked about the interpretation part. Interpretation. So there are two different uh, process of interpretation. Uh, One we have said estimation, and what is another? The other one is testing of
Testing of hypothesis.
hypothesis. So uh, these are the two ways the interpretation means using the sample where our objective is to find the different characteristics, different criteria, different characteristics of the population. Everything about the sample is known and everything about the population is unknown. So we want to estimate, or we want to estimation is a process where we want to uh, we want to approximate the values of the population parameter, and we have said that there are point estimation, there are interval estimation, and we have done a little bit of estimation. Now the other part remains is what is called testing of hypothesis. Now in testing of hypothesis, what is done, some value, in fact testing of hypothesis are of two types. One is called parametric test and the other one is called non-parametric test. So what we do in parametric or non-parametric test, some characteristics of the population is being suggested. In case of parametric test, the population characteristics like the value of mean, value of population mean, value of population standard deviation, and certain other characteristics are suggested, and with the help of the sample it is tested whether the suggestion is correct or not, whether the suggestion is correct or not. And obviously we have talked about the level of significance, level of confidence. So all the tests that we do, there will be certain level of confidence. We cannot do the test with 100% accuracy. We will be saying test at 95% confidence, or in the other way we will be saying test at 5% level of significance, whether this suggestion is correct or not. So testing of hypothesis, in case of parametric test, what we do is we suggest some values of the parameter and check with the help of the sample the whether our suggestion is correct, 95% correct or 99% correct or 90% correct or not. So with some level of confidence, with some level of significance, we test the value of the parameter whether the suggestion is correct or not. And in case of non-parametric test, not a particular value of the parameter is suggested, but certain other criteria has been suggested, and similarly we test the whether the suggestion is correct or not with the level of significance or the level of confidence. And if the test is satisfied, then we uh, we uh, we we conclude that this suggestion is correct or the suggestion is wrong. So that is the process of testing of hypothesis. Before going into the test, we will define certain terminology. So first, let's define what is called a hypothesis. What is a hypothesis? Generally, a suggestion like mu equals to 165 centimeter. That population mean is 165 centimeter. This kind of suggestion, a suggestion, some suggestion about the population is termed as a hypothesis. Some suggestion about the population is termed as hypothesis. There are two types of hypothesis. We denote this. H0 is called the null hypothesis. Null hypothesis is a suggestion where a particular value of the population characteristics or a particular criteria for population characteristic is suggested. For uh, for parametric test, certain value of the criteria, a particular value is being suggested. So if I am writing mu equals to 165 This is a null hypothesis which is suggesting this is a parametric test where the parameter population mu is being tested. Parameter mu population parameter population mean is tested for the value 165, and null hypothesis is that particular suggestion. It always has certain value associated with it. Certain value associated with it. So, and in general, because it's a particular value we are suggesting for the null hypothesis, in general we try to reject the null hypothesis by the test. So we try to reject the suggestion in general, and that suggestion is termed as null hypothesis. Then another term is called H1. We define that as alternate hypothesis. Alternate hypothesis. So what is alternate hypothesis? Anything different from the null hypothesis is termed as alternate hypothesis. So anything different. So if I am suggesting mu equals to 165 is the null hypothesis, then what could be the alternate hypothesis? What could be the alternate hypothesis? The alternate hypothesis could be mu not equals to 165. So mu not equals to 165 or mu greater than 165 or mu less than 165. These three are different alternate hypotheses. So alternate hypothesis is a hypothesis which is different from the, which is separate, which is different from the null hypothesis. Again, please understand that in null hypothesis we are trying to suggest a particular value, a value, and it is highly improbable that a particular value is correct for a population characteristic. So that is why we generally try to reject the null hypothesis by the test and accept the alternate hypothesis by the test. So, like alternate hypothesis, if we suggest that mu population mean is not equal to 165 centimeter in that case, or greater than or less than, so that will be a vast range of values which will be accepting with the with the alternate hypothesis. So these are the definition of null hypothesis and alternate hypothesis. So the testing of hypothesis process goes like this. So every time a test, like uh, given that the sample of 100 students, the average height of 100 students is say 165 centimeter with a variation standard deviation of something blah blah and all that. Now can we say that the population mean is 165 centimeter? Test at 5% level of significance. So this is the term that this will be the question that will be asking, and the process goes like that. What we do to solve this, we will suggest the we'll write this way, that null hypothesis, a particular value of mean, say check whether the population mean is greater than 160. So in that case, what we will do, we will write mu equals to, because population mean is suggested that the value of the population mean is greater than 160. So we will write down this way. We will suggest the null hypothesis as mu equals to 160, and alternatively we will suggest the alternate hypothesis as mu greater than 160, and and by some way we have what we have with us is mu is x bar, that is sample mean is 165 and small size sample size is n, and with this information we'll try to test at 5% level of significance. I think if you remember, I have already said that every time we do a test there will be a level of significance and level of confidence. So 5% level of significance means 5% allowable error, and that means that the result that we'll be getting is 95% correct. So 95% correct means 95% is the level of confidence. So with the help of this information, what we try to do, we try to calculate the value of the test statistic. Value of the test statistic we'll try to calculate, and it depends. The value of the test statistic depends upon the kind of uh, kind of test that we'll be discussing later in elaborately. What are the corresponding test statistics, and if the value false, there will be certain terminologies. We'll be just discussing something called critical region and acceptance region. If the value, so some value will calculate and say something called critical region will define, and something called acceptance region will define. If the value of the test statistic falls in the acceptance region, if the value falls in the acceptance region, we will accept the null hypothesis, and if the value falls in the critical region, we will reject the null hypothesis and accept the alternate hypothesis. So that is the process of testing of hypothesis. We will discuss elaborately. So this is the new terminology that we are defining, called critical region. Critical region, and I will denote that critical region as CR. So C is critical region. Now what is critical region? We have defined what is called level of significance. Alpha is the level of significance. So let's define critical region. So critical region is that region in the graph which corresponds to the level of significance. Critical region is that region in the graph which corresponds to the level of significance. And obviously, if that is the critical region, then acceptance region, I will denote that by CR bar. So CR bar means complement of CR. So CR is the critical region. So its complement will be acceptance. So obviously acceptance region will be that region in the graph which corresponds to the level of confidence. So that means if I say 5% level of significance, 5% level of significance, that will mean that the critical region will be the 5% area of the graph, or probability of critical region will be 5%, and probability of acceptance region will be 95%. Or similarly, because if 5% is the level of significance, then the 95% is the level of confidence. So corresponding area with the level of confidence is the acceptance region. So 95% probability that the value will be accepted, the value will be the result will be accepted. So a level of acceptance is similar to the level of confidence, and that is the area of acceptance region is obviously is a large region, will be the acceptance region, and which signifies the level of confidence, and the level of significance represents the level of criticality, or the critical region. If the value of the test statistic falls in the critical region, so the null hypothesis will be rejected. So by test, when we'll be doing the test, we will check where the, so if this is the critical region, say it could be possible that the critical region will be both the sides, could be one side, we'll discuss that also, could be to the left side, to the right side, depending upon what kind of test we are talking about. So if the value falls in the critical region like here, then we reject H0 is null hypothesis is rejected here or here. If the value falls here, and if the value falls in the acceptance region, so this is the acceptance region with, sorry, in the value of Z, value of the test statistic. If the value falls on the acceptance region, the null hypothesis will be accepted and alternative hypothesis will be rejected. When you reject the null hypothesis, you accept the alternate hypothesis, and the other way around, and that is done if the value of the test statistic falls in the critical region, and the other way around, if the value of the test statistic falls in the acceptance region, then the null hypothesis is accepted and alternate hypothesis is rejected. Now, the test could be two-tailed test or right-tailed test or left-tailed test. These are the three new terminology. Two-tailed test, two-tailed, duto ledge, right-tailed test and left-tailed test. And the test could be of these three types. Now that whether the test will be two-tailed test or a right-tailed test or a left-tailed test, that will depend upon the alternate hypothesis. That will depend upon the alternate hypothesis. Now please understand, we have written the null hypothesis. Just for example, we have written the null hypothesis as mu equals to 165 centimeter. That's an example. Now the alternative hypothesis can be written either as mu not equals to 165 centimeter, or it can be written as mu greater than 165 centimeter, or it can be written as mu less than 165 centimeters. So these are the three possible alternative hypotheses that can be clubbed with one single. Either you can write mu not equals to 165 centimeter, or you can write mu greater than 165, or you can write mu less than 165. That depends upon what is being asked. Like the example that I have given, that our sample mean given 160 got 165 centimeter, and I have asked the question whether the population mean is more than 160 centimeter. That so the question suggests whether the population mean is more than. So in that case, I cannot use the alternate hypothesis this or this. Sorry, not this one, this, because here there has to be some suggestion that me not 165 but 160 in the original example. I think original example, the example that I have given is uh, uh,
160.
right. Then mu equals to, will write mu equals to null hypothesis, will write mu equals to 160, and alternate hypothesis will write mu greater than 160, because the question is asked whether, because sample mean they have got is 165, so they are thinking whether the population mean is more than 160 centimeter. That is what is the question is asked. So accordingly you have to write the alternate hypothesis this way, and you cannot write mu not equals to 160 or mu less than 160, because that will not be appropriate for this particular kind of question. Now, as I was talking about two-tail test or left-tail test or right-tail test, if, please listen carefully, if if the alternate hypothesis is mu not equals to 160, if the alternate hypothesis is not equals to, then the corresponding test is called a two-tail test, and the critical region is distributed in both the ways, both the sides of the acceptance region. The acceptance region will be in the middle, so this is your CR bar, and the critical regions will be both the sides. This is your CR. And how? The area of the critical region will be alpha by 2. This will be alpha by 2. The critical region, because I have said already, alpha is the probability of significance, level of significance, and alpha level of significance corresponds to the level of area, the probability of critical region. And if it is not equals to, if the alternate hypothesis is not equals to, then the critical region will be distributed both the sides, both the sides of the acceptance region equally. So left side also it will be alpha by 2 area, right side will be also, sorry, this is the left side, this will be like alpha by 2, and this will be alpha by 2, so together they will, that area will be together, it will be alpha. So the this will be two-tailed test, the test will be two-tailed test, the critical region will be both the sides. Similarly, if the alternate hypothesis is if mu is greater than 160, then the critical region will be termed as a right tail test because the critical region will be at the right, and this will be alpha in that case. This point will be Z alpha. আমার আগের ছবিটা আঁকা উচিত ছিল for the previous one, mu not equals to 160, mu not equals to 160. This is Z alpha by 2. This point is কে বলবে? Who can tell me? What is the denotation if this is Z alpha by 2? This is
minus z
Z alpha
alpha.
by 2. That means this area is alpha by 2. This also area is, আচ্ছা এটা z হবে কি হবে, কিও হতে পারে, that depends upon the test, but for an example I'm just, so this area is also alpha by 2, this area is also alpha by 2. So this is for the two tail test. The critical region will be distributed in both the sides. For right tail test, mu is greater than 160, then the critical region will be to the right of the acceptance region, and this area will be alpha, and this point will be Z alpha. This part, the whole part will be the acceptance region. This part will be the critical. This is the CR, and this part will be the CR bar. So it will be right tail test when the alternate hypothesis is greater than, and if the alternate hypothesis is mu less than 160, then it will be a left tail test. So this will be minus Z alpha minus. This is your acceptance region, that is CR bar, and this is your critical region, that is CR, and this area will be alpha. So please get your head cleaned. Listen what I'm saying. This concept is very important. If it's a two-tail test, the critical region will be both the sides, and it will be distributed equally, alpha by 2 and alpha by 2. If the test alternate hypothesis is greater than, then the critical region will be to the right of the acceptance region, and the area will be alpha. Whole area will be alpha to the right. If the alternate hypothesis is less than something, then the critical region will be to the left, and that is how it will be distributed. The tests will always be either a two-tail test or a right-tail test or a left-tail test. That will be decided by the question. That what will be the alternate hypothesis, that has to be decided from how it is, what is the question that has been asked. So it is very important to write down the null hypothesis and the alternate hypothesis for a particular problem to solve. You write the null hypothesis, you write the alternate hypothesis, then you write down whatever the given values are, then decide what will be your test statistic, then calculate the value of the test statistic, then draw the corresponding graph of the test statistic, then place the value of the test statistic and check where the critical region is. Critical region depends upon the alternate hypothesis. If the value of the test statistic falls in the critical region, you reject the null hypothesis and accept the alternate hypothesis. Otherwise, if the value of the test statistic falls in the acceptance region, accept the null hypothesis and reject the alternate hypothesis and write the decision. So that is the decision making process, that is the interpretation that will be done through the testing of hypothesis. Is it okay? Let's go to the next part where we discuss certain terminologies. Now please listen very carefully. Now assume, now what are the possible types of errors? Errors in testing of hypothesis. Or what are the possible kind of mistakes that we can make? Now please try to understand, this is very important. No, as we have said, in testing of hypothesis, what we do, we suggest some value of the null hypothesis and check whether that is correct or not. That's the process. Please reply, students, please reply. So now, what are the possibilities? Say this is null hypothesis. What are the possibilities? Either null hypothesis can be either null hypothesis can be true, or the null hypothesis can be false.
false,
Is there anything in between? Either it is true, meaning it's quite possible whatever is suggested that is true, or the other alternative is if it is not true, obviously it will be false. ঠিক আছে আচ্ছা I'll just write one thing. uh, TS means test statistic. I'll denote the test statistic at TS. TS is the value of the test statistic. Why I'm saying this is a statistic? Because it will be obtained through the use of the sample. As I've said, everything about the sample is known, and our objective is to looking at the sample, our we have to decide about the population. That is the basic thing we are trying to do. Always we are trying to do. Looking at the handful of rice, whether it is being cooked or not, we will decide whether the whole bowl of rice, whole হাঁড়ির রাইসটা সেদ্ধ হয়েছে কিনা সেটা কিন্তু চেক উই ক্যান অনলি ডিসাইড ইফ এক হাতা ভাত তুলে নিয়ে চেক করছি দ্যাট handful of rice is cooked or not. So depending upon that, we will decide whether the whole rice is cooked or not. So that is the part of the sample, and that is the population. So looking at the sample, we are trying to decide about the population. So as we are saying, so null hypothesis could be true or it could be false. Okay. So then what are the two possibilities? Null hypothesis is true. Now, how we are deciding about the null hypothesis? That whether TS belongs to CR and whether TS belongs to CR bar. What is the meaning? TS means test statistic belongs to CR bar. What is the decision in that case? আচ্ছা আর একটু ভালো করে লিখি সো মাঝখানে A0 is true or false. Either, I don't know whether it's true or false. Either the null hypothesis could be true or the null hypothesis could be false. But the decision depends upon Kiki. TS belongs to CR bar or sorry small ts or TS belongs to CR. Ekhetro, in this case also TS belongs to CR bar and TS belongs to CR. Please try to understand কি বলতে চাইছি. So what I'm saying is null hypothesis either could be true or could be false. But the decision depends upon where the test statistic falls, where the value of the test statistic falls. Right? So say suppose I'm drawing this. So if the value, this is the critical region and this is the critical region. So if the value of the test statistic falls in the CR bar means TS belongs to CR bar. What does that mean? What does that mean? Who can tell me? TS belongs to CR bar means
accept
yes,
region,
value of the test statistic falls in the acceptance region. তাহলে আমরা কি করব? What we will do? We will accept the null hypothesis. As I've said, if the value of the test statistic falls in the acceptance region, CR bar is the acceptance region. So if the value of the test statistic falls in the acceptance region, we will accept the null hypothesis. So what is happening here? Who can tell me? Who can tell me what is happening here? We are accepting the true null hypothesis.
accept,
We are তাই না? The null hypothesis is true and the value of the test statistic falls in the acceptance region, CR bar, mind that. So here what is happening? We are accepting. So I can write this probability that we'll write this way. Uh, so probability null hypothesis is true, and TS belongs to CR bar. তার মানে what is this? This is something good that is happening. তাই নাকি? We are accepting, so this implies accepting the null hypothesis when it is key, when it is
True.
when it is true. Accepting the null hypothesis when it is true. So something which is very good. ভালো জিনিসকে যদি তুমি accept করো, that is really good. Like the discipline you maintain by attending the class. 10:30 class, you attend the class. That's very good thing that you are doing. Okay. So that's the first part. Now look at the second part. So A0 true, TS belongs to CR bar. এটা একটা ছিল, আর একটা হচ্ছে TS belongs to CR.
CR.
Sorry, TS belongs to CR. So that's the second part. So if TS belongs to CR, then what will happen?
Critical region.
So what will happen? TS belongs to critical region, মানে value of the test statistic falls in the critical region. তার মানে এটা হচ্ছে critical region, ভ্যালুটা এখানে পড়লো, so value of the test statistic fall is in the critical region. What will happen if the value of the test
Accepting the null hypothesis.
no, if the value of
Reject null.
will reject the
Reject
will
null,
not
accept
accept the
alternate hypothesis.
so we reject the null. That means although the null hypothesis is true, you are rejecting it. Although the null hypothesis is true, you are rejecting it. That means true null. So this is we will be terming this as probability H naught is true. H naught means null hypothesis is true. TS belongs to CR. This implies rejecting the null hypothesis, although
It is true.
it is true. What is this? Is it good or bad?
Bad.
Bad,
This
sir.
is so this is a error that is happening. This is a very bad thing that is happening. This is a bad thing. This is happening. This is bad. In fact, this is called type 1 error. This is called type 1 error. So probability null hypothesis is true, but TS belongs to CR. So rejecting the true null hypothesis is type 1 error. Also, there is another term which is called producer's risk. This is called producer's risk. I'll just give an example. Rejecting the null hypothesis when it is true is called the producer's risk. So, rejecting the null hypothesis when it is true is called the type 1 error, or there is another terminology that's called producer's risk. How it is producer's risk? Let's talk about an example. So I think I've talked about think about this. Please try to follow what I'm saying. So every day there are 10,000 bottles are being produced, and for quality control department, what they do, they randomly pick up 100 bottles to check. So say on today's batch there are 10,000 bottles are produced, and from them, so this is your population and this is your sample population and this is your sample. So you check this sample and decide this 10,000 bottles will be good for selling in the market or not. So what you do, so you have the decision, the decision is, if the decision is like that, if three or more bottles are out of 100 bottles, that means 3% error. If three or more bottles are something wrong in three or more bottles, then we will reject this. Okay? So three or more bottles means in 100 there are three, in 10,000 this is 300 bottles, তাই তো? So 299 হলো, that is past. Are you following কি বলতে চাইছি? বুঝতে পারা যাচ্ছে? তো যদি তিনটে
Yes, sir.
100টার মধ্যে যদি তিনটে বটলে কোনো রকম ডিফিকাল্টি হয়, টিকটিকি লেজ আছে কি, whether the smell is wrong or the level of cold drink is less, whatever, something, anything, any defective item. So if there are three or more defective items are there out of 100, then the whole lot will be rejected, and that's, so 100 bottles are being picked. Now what happened in this 100 bottles, it is found that 5 bottles are defective, but actually in 10,000 bottles there were say 220 defective bottles are there, suppose. So 220 defective bottles means 2.2, which is less than 3. কি বলছি বুঝতে পারা যাচ্ছে? তাহলে 300টার নিচে আছে, তার মানে অ্যাকচুয়ালি ডিসিশন অনুযায়ী ওর পাস হয়ে যাওয়া উচিত ছিল, কিন্তু বিকজ অফ র্যান্ডম স্যাম্পলিং আই হ্যাভ ডান, আনফর্চুনেটলি ওই 220টা থেকে 5টা বটল আই হ্যাভ পিকড ইন 100 বটলস। ইজ ইট পসিবল? 100টার মধ্যে 5 bottles are defective and 95 bottles are good. Is it possible I can pick 5 wrong bottles? It's quite possible because I am picking randomly. Do you get my
Yes,
point?
sir.
কি বললাম? 100টার মধ্যে
Yes, sir.
100টার মধ্যে 5টা means my limit was 3, but here 100টার মধ্যে 5টা, so that means what the producer is thinking, this sample is bad, but actually this sample is good because 10,000টার মধ্যে 220টা ছিল in originality. So null hypothesis was true. In originality, out of 10,000 bottles there were 220 wrong bottles. So but in 100 bottles there are 5 wrong bottles, 5 defective bottles. So that means the producer thinks na এই ব্যাচটাতে অনেক বেশি ডিফেক্টিভ বটলস আছে, so he rejects this lot. This 10,000 bottles will not be given to the market, will not be sent to the market for selling, because the experiment shows, the sample shows there is a lots of the tolerance level এর চেয়ে অনেক বেশি এখানে defective bottles আছে, so you cannot, so that is why it is the producer's risk, because it is producer has produced it but cannot sell it and earn it profit, so that is why it is called producer's risk. So the above part, the true part is done. So null hypothesis is true if the value falls in the acceptance region, so we will accept the true null hypothesis, so that is happening, that is good. But if it happens the other way around, that is if the test statistic falls in the critical region, we will be rejecting the true null hypothesis, and that is something bad, and that is called the type 1 error or producer risk. Now what happens to the other part? If the null hypothesis is false, similarly একই রকম ভাবে এখানেও তাই হবে, if the TS belongs to CR bar and TS belongs to CR, তাই তো? আমি সেই null whether I will be accepting the null hypothesis or rejecting it, that depends upon where the value of the test statistic falls. এবারে আগের বার আমরা ধরেছিলাম নাল হাইপোথিসিস আইদার কুড বি ট্রু অর নাল হাইপোথিসিস কুড বি ফলস। Now we have already discussed if the null hypothesis is true, that part. Now if the null hypothesis is false, if the null hypothesis is false, so whether the false null hypothesis will be accepted or rejected, that depends upon the whether the value of the test statistic falls in the critical region or acceptance region. If the if the test statistic falls in the critical region, what will happen? What will happen if TS belong? If this is TS. If TS belongs to CR, then what will happen? Then we will bolo please say something. If value of
Reject.
the test statistic falls in the
Accepted.
critical region, then
Rejected.
then এতক্ষণ ধরে কি বলছি? Then the null
So reject null hypothesis and accept alternate
yes,
hypothesis.
then we'll reject the null hypothesis. একই কথা তো বারবার বলছি, then we'll reject the null hypothesis. So the null hypothesis is false, and if this is happening, what we are doing? We are rejecting the false null hypothesis. Is it good or bad? Is it good or bad?
Good.
So bad.
Good, sir.
Good or bad? Somebody said
Bad.
bad. It is good because here we are assuming, so this probability is null hypothesis is
Good, sir.
false. So null hypothesis is false and TS belongs to CR. So the value of the test statistics falls in the critical region, and if the value of the test statistic falls in the critical region, we will reject the null hypothesis. So reject the null hypothesis, and that is false. False null hypothesis. This implies what we are doing. We are rejecting. Please write. Are you writing? We are rejecting the null hypothesis
Yes, sir.
when it is false. We are rejecting the null hypothesis when it is false. Is it good or bad?
Good.
Yes,
Good.
obviously.
This
খারাপ
is good.
খারাপ জিনিসটাকে রিজেক্ট করাটা সবসময় ভালো, বাট আমরা রিয়েলিস্টিক্যালি তা করি না।
Good.
আনফর্চুনেটলি ইন রিয়েল লাইফ উই ডু নট ডু দ্যাট। ফেসবুক আর করা হোয়াটসঅ্যাপ। নাও হোয়াট হ্যাপেন্স টু দ্য আদার পার্ট? সো নাল হাইপোথিসিস ইজ ফলস। We have written TS belongs to CR and TS belongs to CR bar. So if the null hypothesis is false and that value of the test statistic falls in the acceptance region, then what will do? Then what will do?
Accepting null hypothesis
Hypothesis when it is
when it is
false.
true.
When it is false, true কোথা থেকে হলো?
Sorry,
True
sorry,
উপর
sorry.
দিকে।
Sorry,
Accepting the null hypothesis when it is false.
false.
Actually, this is what is called type 2 error. This is something very, very bad. Accepting which is wrong. Accepting which is wrong. Accepting the null hypothesis. So probability that A0 is false, but TS belongs to CR bar. So we can write probability null hypothesis is false, A0 is false, but this is called conditional probability. This is a conditional probability. TS belongs to CR. CR bar means acceptance region. So if the value of the test statistic falls in the acceptance region, the null hypothesis will be accepted. So we are accepting something which is false. So accepting the false null hypothesis. So which is
Bad.
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 And this is called type 2 error. This is called type 2 error. Or there is another name. This is also called the consumer's risk. Consumer's risk. কিরকম? Same example, 10,000 unit, there are in the population, there are 10,000 bottles are being there. In the 100 has been picked as a sample. ঠিক আছে, কি হবে এক্সাম্পলটা একটু চেঞ্জ করো তো দেখি কি করবে। In the 10,000 bottles there are 425 wrong bottles, but in the sample there are 2 wrong bottles, 2 হতে পারে তো। I have taken the random sampling, I have picked up 100, কিন্তু তার মধ্যে I have found out 2 bottles which are defective, but in the original there are 425 bottles which are defective. কিন্তু since I have picked up randomly, I have picked up only 2 defective bottles, তাহলে কি করব? তাহলে অ্যাকর্ডিং টু আওয়ার নর্ম এটা less than 3 রয়েছে, so I'll decide what I'll decide that this batch is good, তাই তো? Are you following?
Yes, 4.25 is greater than
Yes, sir.
Yes, 425 is greater than 300, but the
yes.
sample says other ways. So what we'll do, I'll decide that this batch is good, so I'll send this to the market. The producer will send this to the market for selling. Then you are a consumer, you buy one of the 425 bottles. Got it? You, as a consumer, you buy one of the defective bottles and then say, oh, it's a defective bottle. You have got a defective bottle. So that is why it is a consumer's risk. বুঝতে পারা গেল? Because it is already sold in the given for selling in the market. So that is why it is called consumer's risk. So now tell me which one is deadlier? Whether consumer's risk is deadlier means কোনটা বেশি খারাপ? Consumer's risk is type 2 error or type 1 error? Which one is more মানে badder, I can say? Who can tell me? Quickly, 10টা 11টা 37, 11:37.
Sir,
So consumer's risk or producer's risk?
The
Which one?
consumer is,
Or producer risk? Which
sir,
one is?
consumer risk.
sir,
Or
producer risk.
why?
Consumer
If
risk.
it is consumer risk, why? If it is producer risk, why? Tell me.
Sir,
Sir,
because producer is producing a large amount, so I feel the producer's risk.
Okay. And what
Sir,
about the
in
consumer risk?
consumer, it can affect the goodwill.
Yes, actually, in real life, consumer's risk is better than the producer's risk, because producer has another alternative. He can do, because you will be learning in quality control. You can do the acceptance sampling. They can check another sample and do some other things also to find out what are the difficulties with the, and you can segregate those things. But consumer risk is there in the market. So yes, as she has said, the goodwill will be affected if you get that product, that wrong product, defective product. You will be thinking second time when you will go for buying the product for the second time. Isn't that true? As a consumer you will also think,
Yes, sir.
আমি কি ওই প্রোডাক্টটা আবার কিনতে যাব? এইটা আগেরবার আমি যে মডেলটা কিনেছিলাম সেটা বাজে, লেটস ব্র্যান্ড চেঞ্জ মাই ব্র্যান্ড, অন্য কারোর কাছ থেকে কিনবো, অন্য কিছু কিনবো। সো that adds to the producer's goodwill, as well as affects the affects the profit and all that. So producer,
Yes, sir.
when uh, he has some other way of changing that and rectifying that, but when it is in the market, the producer don't have the way of changing that. So producer's risk is lesser than the consumer risk. In fact, the other part is the, if rejecting the, I'll just take 2 more minutes. Rejecting the false null hypothesis is called beta. The other part is called the power of the test. Please write. So when null hypothesis is false, H0 is false, F. H0 is, when H0 is false, আমি ট্রু পার্টটাতে যাচ্ছি না, ফলসের দিকে, and TS belongs to CR bar, sorry CR, TS belongs to CR. So this part, That means you are rejecting the null hypothesis. So rejecting the null hypothesis when it is false. This is called beta or power of the test. Sorry, I'm making a mistake. This is called 1 minus beta or called the power of the test. In fact, this is called beta. Type 2 error is termed as beta. Type 2 error, probability of type 2 error is termed as beta. So, beta is called the type 2 error. Those students who will be doing the finance specialization, these things will be very important for them. In fact, for marketing students also will be taking. So, beta is called the beta is the type 2 error, probability of type 2 error. So, what is that probability? Probability H naught is false and TS belongs to CR bar. So this is actually, this is beta or probability of type 2 error, and 1 minus beta is called the power of the test. It's called the power of the test. Okay, so these are the terminology, these are the very important discussion I have done. So please go through the discussion again.